Okay, in this video, I'll show you how to find peaks from a given periodic data. So let's say we have data as shown here. This is vibration data, and we would like to find the peaks of the data. So the first step is you need to know the time period. So you can manually figure this out by finding the time difference between two peaks. This is called the time period, TD. We're going to use that information and then break down our data into little search ranges. So you can have, this is going to be one range, for example, and then there's going to be another range. And then we'll use the max function within each search range to figure out what is the peak value. Okay, the peak value is found here, and you will also find the index at which the peak value occurs, and this should give you the peak time as well. Okay, so let's see how to do this in Excel. So here we have some vibration data. Let's label our data first. So this column is going to be our time vector, and this column is going to be our voltage. Okay, now let's plot it. So select your data and then insert a plot. Okay, let me move this to the top of the page. So let's cut it from here all the way to the top and paste it here. Now you can zoom in on this by changing the x-axis. So you can right click, go to format axis, and then let's change it to 0.02, for example, or 0.1. Okay, so to get a rough estimate of what's the time period, we'll keep your mouse cursor over here, and you'll get the x and y value for that particular point. So the x value here is 0.0188. So let's write that down. And for the next peak, it's roughly around 0.0386. 0.0386. Okay. So the difference between these two is this minus the first value. Okay, so we need to know how many samples exist in each cycle. So this is your time period TD. Okay, so between each cycle, you can see the sampling rate is 1 over this value. So that's going to be equal to 1 divided by this value. So this is a small time step between each sample. So 1 over that time step will give you the number of samples per second. So we're collecting 10,000 samples every second. So how many samples consist of this? You can just multiply this and the sampling rate together. So rate. Okay, so sample per cycle is going to be equal to this is the time taken for each cycle multiplied by the sampling rate. You have about 198 or 200 data points in each cycle. So we're going to split our data into search ranges of 200 data points and then find the peaks for each search range. Okay, so we'll start here as search range. We start from the first search range, and the next search range should start at 198. Okay, so that's the constant. So it's going to be the first search range plus 198. So this way you can incrementally go through all different search ranges. Sorry, select the last one. This way you can incrementally go through each cycle and find the max value for that particular cycle. To find the max voltage or find the peak, so this is the peaks. Okay, you can just use the max function, but instead of you looking at the entire data, you look at an offset of the data. So your reference is this first value here, and the row offset is this one. Okay, column offset is 0, and total height is the entire search range, which is 198 samples. Okay, and then close the bracket, close the bracket. Okay, this will give you the first peak value, and you can kind of see where it occurs. 0.01, it's referring to this peak over here, 0.01036. So it's actually this value. And then you can just expand this formula down Okay, so we by mistake shifted the total sample, so you need to make it a constant. You can click on this final one and press F4 on your keyboard to make it a constant. Okay, expand your result. And these are the different peak values. Now we will also like to find the time at which these peak occurs. So in order to find the time, we need to find the index at which these numbers occur. So you can use the index, the match function to find the index. So, and then you are looking for the peak value. So this is the peak value, and you're looking for it in the same range that you looked for for the peak. So we go here, we need to copy this range, copy, and then put it here. So match the peak value within the same range. Okay, and we want to find an exact match, so put a 0 at the end. And this will give you the offset at which it occurs within that subset. Okay. Now, if you expand this, you'll see that the numbers are in between 0 and 198 because they're looking for the index within a given subset. So to find the actual index or the actual row number, we'll have to add the offsets to this to the index. So at the very end, just say plus this number. Okay. Now, if you expand it, you'll get the increasing index. So you can think of this like now we are in the absolute index. So now we have the indices for where the peaks occur. You can use the indices to find the time value from the time vector. So there is a function called index, which given an array and an index number, it will return the value from that column. Okay. So this is where the first peak occurs. So you can see this is 0.01, and that's where the peak value occurs. And you can just expand this down. Okay. We can then plot the peak values in our plot. Just right click on your plot, select data. Let's call the first series here the measurements. And then we'll add a new series, we'll call it peaks. And the x value is going to be the time that we just plotted, the time we found, and the y value is going to be the peaks. Click OK. Click OK. By default, it draws a line plot. To change this, you can go to Design and go to the Design tab, click on Change Chart Type, and then go to Combo. And then for the first one, the measurements, you can choose a line, scatter line, and for the peaks, we can choose a scatter dots. Okay, but make sure the secondary axis is unchecked, otherwise you will get disassociated data as shown here. So uncheck this so that they plot on the same scale. Click OK. And we can zoom in over here. Just right click on your x-axis, go to format axis, and decrease this to 0.1 for example, or 0.2. And you can see the peaks are being plotted over here. Now there might be some small artifacts. So for example, it's missing this peak here. This might be due to the fact that the range might be cutting off over here. So in order to avoid this, you can slightly shift your search ranges. So instead of starting at 0, because you can see there's a peak exactly at 0, so we can start maybe at around 20, after 20 data points. And this will shift the peaks and you'll get a more ordered data set. Okay.